In this video, I'm going to show you how to evaluate logarithms using the definition for natural exponents. For example, here we want to simplify the equation x equals log base 2 of root 2 without using a calculator. Now, the key thing to remember to simplify logarithms is this rule. For any number a, log base a of the number a raised to some power y is always going to be y. As long as the base of the log matches up with the base of the exponentiated term inside of the log, then the log just outputs the exponent of that term. Okay, so looking at our equation here, we've got a base of 2, and we'd ideally like to rewrite this argument of the log, root 2, so that it has a base of 2 raised to some exponent. So we'd like to be able to say that x is equal to log base 2 of 2 raised to some power. So 2 raised to some power, call it y. That way, the output of the logarithm will just be that exponent on the 2, which is y. To make this idea more concrete, why don't we do a few examples first? So suppose we had log 2 of 8. Well, if we had log 2 of 8, then we could just write 8 as 2 to the third. It'd be log 2 of 2 to the third. And then since the bases matches up, bases are both 2, then the output would just be the exponent, 3. Likewise, if we had log 2 of, say, 1/2, then we could write a half as just 2 to the negative first power. And then since the bases matches up again, the exponent would be the output, just -1. Okay, so why don't we tackle the actual problem now? So this is log base 2 of 2 to some exponent, and we need to figure out what that exponent is. So let's write 2 to some exponent, and now let's actually fill in what the exponent is. So inside of the log here is root 2, and we can write this as a number with a rational exponent. Root is just exponent of a half. So root 2 is just 2 to the 1/2 power, and then log base 2 of 2 to the 1/2 power, you just take the power, and that's just 1/2. So there we go. There we're done. X is just 1/2. The equation just simplifies to x equals a half. Here's another example. This one's a little bit trickier because we've got multiple terms here, and also one of them has a fraction. But nevertheless, let's go on and do this. We want to simplify this equation. X equals log base 3 of root 3 plus log base 2 of 1 over cube root of 2. And we want to do this without using a calculator again. Okay, so first step here, let's try to write these arguments of the logarithms so that they are the bases exponentiated by something. So let's go ahead and write this down. So we need x to equal log 3 of 3 to some power. So how do we turn this root 3 into 3 to some power? Well, again, the root is just a rational exponent. That's a rational exponent of a half. So just root 3 is just 3 to 1/2. And okay, so we're done. We'll be able to simplify that in the next step. Just take the exponent. Now let's worry about the next logarithmic expression here. Log 2 of 1 over cube root of 2. Okay, so this one's a little bit trickier, but why don't we see how we can simplify this? So this will be plus log base 2 of 1 over cube root of 2. Why don't we start by, again, turning this into a rational exponent? Square root goes to exponent of a half. Cube root goes to exponent of a third. So we'll change this into 1 over 2 to the 1/3. Okay. So we're a little bit closer to where we want to be. We want this to be just 2 to some power, but we're not quite there yet because right now that's 1 over 2 to some power. So let's do another step and simplify it even more. So x is equal to log base 3 of 3 to the 1/2 plus log base 2 of what? So 2 to the 1 over 2 to the 1/3 power. What's that equivalent to? Well, we can get the 2 out of the denominator of the fraction by just tacking on a negative into the exponent. So make this 2 to the negative 1/3. That's equivalent to the argument above. And there we go. Great. So we've got log base 3 of 3 to some power plus log base 2 of 2 to some power, and we're ready to go ahead and simplify. So let's do that. That's just x is equal to log base 3 of 3 to 1/2. The bases matches up, so we just take the exponent 1/2, and then plus log base 2 of 2 to the negative 1/3. So bases matches up again, so we take the exponent negative 1/3. And then it's just a matter of adding the fractions. So x is equal to, why don't we make these both over 6? That's the least common denominator. So over 6, that's 1/2 is 3 over 6 multiplied by 3 on top and bottom, and then minus over 6, multiply top and bottom by 2 here, so minus 2/6. So x is just 1/6. Here's a final example. We want to simplify this equation. X equals log base 25 of 4th root of 5 plus log base 3 of 1 over root 27. And this equation is even tougher than the previous one because now we don't even see our base of the logarithm in the arguments of the logarithm. We're going to have to manipulate our arguments of the logarithms somehow to make a base arise in them. That is, we want to be able to write this 4th root of 5, we want to write that as 25, the base of the logarithm, raised to some power, say y. And likewise, we want to write this 1 over root 27 as the base of the logarithm raised to some power, so 3 to some power z. Okay, so why don't we start out with this 4th root of 5. Write that over here. 4th root of 5. How can we write that as 25 to some power y? Well, why don't we start by looking inside of the root. This is just the 4th root of, can we write 5 as 25 to some power y? Well, 5 is just the square root of 25, so 5 is just 25 to the 1/2 power. And now that we've got a 25 to the 1/2 power, we can think about this 4th root on it as a rational exponent. So this is like 25 to the 1/2 power to the power of 1/4. And when we have an exponentiated expression raised to another exponent, we just multiply the exponents. So that's 25 to the 1/2 times 1/4, or just 25 to the 1/8. Okay, now how about that 1 over root 27? Let's write that over here, 1 over root 27. I want to write that as 3 to some power z, and we'll take the same approach. So start off by writing 27 as 3 to some power z. 27 is just 3 to the 3rd power, so write that as 3 to the 3rd here. And now let's interpret that root as an exponent of 1/2. So this will be 1 over 3 to the 3rd to the power of 1/2. And now we can just multiply the exponents. So that's 1 over 3 to the 3/2. That's 3 times 1/2. And now our last touch to get 3 outside of the denominator of the fraction, we can just flip the fraction and put a negative on the exponent. So that's just 3 to the negative 3/2. Great, so now let's put these numbers in for the arguments of our logarithms. 25 to the 1/8 will go in for the 4th root of 5, and then 3 to the negative 3/2 will go in for 1 over root 27. And let's write down what x is again. So x is just log base 25 of 4th root of 5, which we're substituting 25 to the 1/8 for that. 25 to the 1/8, and then plus log 3 of 1 over root 27, but we're putting in 3 to the negative 3/2 as an equivalent form. That's easier to work with now. So great, so now the bases matches up, 25, 25, 3, 3, and we've got x is just equal to the exponent here, 1/8, and then plus the exponent here, negative 3/2, so 1/8 plus negative 3/2. And why don't we, to compute that, let's get a common denominator. How about common denominator of 8, so 1/8, and then plus over 8, you just multiply by 4 on top and bottom, so plus negative 12, so x is just equal to negative 11 over 8. And there we go, we have it. Now we're getting pretty good at evaluating logarithms, and in the future, we'll also learn how to use logarithms to find the exact solutions to simple exponential equations.